Today we're going to learn how to write formulas of ionic compounds using the crisscross method. Now, in our last exercise, we learned how to figure out how many of each of the types of ions we would need in order to have a ratio that would make a neutral compound. So today we're going to kind of shorten that up, but let's take a look at what we did before. In this block, we want to bond sodium with chlorine. We have sodium and chlorine. Sodium has a positive 1 charge, chlorine has a negative 1, and so in this case, to have the ratio where we would have a neutral atom, we would just need one of each. So in this box, we'd put NaCl. Easy. Now this next one, the carbonate, the sodium once again have a positive 1, but our carbonate has a negative 2 charge. So we would need 2 of the sodiums in order to make a neutral compound. So that would be Na2CO3. Now have you noticed that when we do this, that the charge on the 1 ends up being how many of the other ones we need, and the charge on the first one is how many of the second ion we end up needing. And so we shorten this up to do what's called the crisscross method, where what you do is when you have 2 ions, we would have sodium Na plus and our carbonate CO3 minus 2, we do what's called the crisscross or swap and drop, where you would swap, you bring down the oxidation number, and then the drop is you're going to drop the charges, the oxidation number, and just write your compound. So this would be our formula, our lowest ratio for the compound. Let's do one with a polyatomic ion, the only one that is a positive charge, the only one of our polyatomic ions, NH4 ammonium, that is a cation. So how we would do this, we would write it NH4 with a plus, our chlorine with a minus 1. You'd swap, bring down the 1 and the 1, and the drop, the cleanup. You don't have to write the 1, and we're going to drop our charges. So it'll just be NH4Cl. NH4Cl. Ooh, let's do this one. It looks hard, but it's not going to be. All we have to do is our ammonium, NH4 with a plus, our carbonate, CO3 with a minus 2. We swap, we bring down the 2, bring down the 1, and then we're going to drop. We're going to clean this guy up. It would be NH4 with a parentheses. That parentheses is telling us that we need 2 of all this whole polyatomic ion, and CO3. NH4 CO. I'm almost running out of room. Okay, let's do an easier looking one. Let's try this calcium. So let's do calcium chloride. You start with writing calcium, Ca, 2 plus, our chlorine, Cl minus. We swap, bring down the 2, bring down the 1. Now let's clean it up. We drop the oxidation numbers, and we don't have to write the 1. If there's nothing there, we assume it's 1. So this is calcium chloride, CaCl2. Now remember, we're looking for the lowest ratio, so let's look for one that we need to reduce. How about, let's look at this magnesium. Magnesium, let's do magnesium carbonate. So we're going to do the magnesium and the carbonate. Magnesium, Mg2 carbonate CO3. I'm going to swap. And now I need to look just to make sure we're looking for the lowest ratio. So there's a number that will go into both of these. 2 goes into 2 once, 2 goes into 2 once. And now we're going to clean this whole thing up. We're going to write MgCO3. We don't write the charges and we don't write ones, and that is our lowest ratio. Let's find one that we need to. Now that's we'll do the zinc hydroxide. We'll do one last one, and then we'll let you guys finish these on your own. Zinc hydroxide. We're going to write the Zn2. Hydroxide, OH, that's on your polyatomic ion list. OH negative. We do the swap. I bring down the 2. I bring down a 1. There's no lower ratio, so I'm going to clean this guy up. Zn. And I need the parentheses because I'm telling people we have 2 of the hydroxide ion. So there's going to be 2 of this whole thing, 2 oxygens and 2 hydrogens. So we have to have that parentheses when we use the polyatomic ion. Good luck with the rest of the worksheet.